Hi class, it's Bill Berry back with a video that is an important one for our Java 2 projects, and that is the idea of running Xlint. So this is something that is going to be new, I believe, to all of you. It's not something that we talked about even in my 142 class, so this is something extremely useful for programmers who are starting to work with data structures, because we can certainly cause ourselves problems, and it's nice to know about an extra layer of protection that we can run and sort of really dig in and see if there are errors below the surface that maybe we should know about. So let me grab a marker just in case I need it, and then let's jump down to that slide. All right, so what is Xlint? Xlint is an extra tool that is available in the compiler, and this is common. You'll see this, the term lint. When you hear that in the programming world, this is a common idea, and that is you want to go a little deeper. You want to find the dust bunnies, right? You want to find that lint that's a little bit deeper in your code that the compiler wouldn't necessarily find. Well, why doesn't the compiler find everything? Well, we're going to talk about that. The compiler, for a lot of purposes, is just going to make sure that the basics are okay, and a deeper look would make certainly beginners work an awful lot harder to fix certain problems that they may not need to worry about. But certainly as a professional programmer, we want all the information we can get, right? We want every single bit of detail about anything we might be doing wrong. We can always choose to ignore it or choose to suppress it if there's a need, great, but we want to be able to run Xlint. So the other thing is, for your projects, you will be required to run Xlint. So if you will read the submission guide, it's going to tell you how to package your stuff up, and it's going to say, before you turn this stuff in, run Xlint. In fact, I wouldn't wait till right before you're ready to turn in. When you get to a stopping point in your project, a reasonable point where you think you've got a lot of the stuff developed, run it then, right? And then just run it again, just to make sure at the end. So that's what Xlint does. First of all, let's talk about the types of exceptions that exist in the Java world. You are familiar with, even though you may not have called them by name, checked exceptions. So checked exceptions are so important and so frequently run into that Java has put in the compiler a check for those kinds of things and forced you to deal with them. For instance, when you're dealing with files, surely you've seen this, that you are required to either have a try catch or to throw the file not found exception, right? It just happens because it's so common that the file's not there, file's been moved, file's not named right, whatever it is. So file not found exception is one of those checked exceptions that Java just forces you to do. Make a try catch, put a throws, but somehow deal with it, right? And that is going to be inherited, right? That's a child of the exception class, fine. That's checked at compile time, and as I just said, the compiler requires you to handle it. Now, do you write an @throws tag? Well, typically not. You could, but actually with this one, with a checked exception, and if you have the @throws tag on your definition line, then it'll automatically be added by the documenter. So typically you don't need to do anything about throws here, right? You don't need to put that tag in your JavaDoc documentation. But what other kinds of exceptions exist in the world? There are unchecked exceptions. These are things that the compiler does not force you to deal with. These are things that typically happen at runtime. Well, so does file not found exception, but they happen at runtime, but they're things that you don't necessarily run into all the time. They're things that hopefully you know to deal with. For instance, array index out of bounds, right? If you don't have a check to make sure that your bounds are good on your parameters and things like that, typically you think to do that, and you're careful with your loops, so often you don't see array index out of bounds. So that's an example of an unchecked exception, right? Now, this is also a child of runtime exception, which is a separate branch, right? It's a special kind of exception called a runtime exception, and those are not checked for you at compile time, right? So when you're working with arrays, you never had to deal with this unless you chose to deal with it. You aren't asked to mark it or catch it or anything else, right? The compiler is not going to say anything. When do you add the @throws? Well, put the @throws if and only if you think that the calling code, right, the client code, will want to actually put a try catch around it. If you think it's something that they should put a try catch around, then by all means add an @throws JavaDoc tag for that. But otherwise, you don't need to necessarily do it. Just describe it in the parameter tag as usual. Now, why am I worried about this stuff now? Well, we're going to be writing a lot of stuff about collections and data structures this quarter. When you use generics, there are some really critical things that you can run into. They are unchecked exceptions, but if you don't take care of them, you are going to be in in more serious hurt than usual. These things are going to really have an impact on the type safety of what you do, and you don't want to be writing code that is not type safe generally. So in this case, for our course, we are going to certainly want to know about any kind of unchecked exceptions, and we're going to want to know to fix those, right? We're going to go and take care of it and do things properly so we don't have those unchecked exceptions. So you're going to run Xlint until you have a clean Xlint run, right? You're going to go fix all that stuff. So that's exceptions and unchecked exceptions, so that's one big one. So we can tell Xlint, hey, please go find our unchecked exceptions and tell us about them so we can fix them. Then there's one other thing that we need to talk about. It's another thing when you create generics and when you're working with collections, it's a very common kind of mistake. It's called a raw type. What is a raw type? That's when you use a class or an interface that wants a generic, right, that wants a type parameter, but you don't include it, right? So for instance, array list, if you look at the array list definition will say angle bracket T, right, or angle bracket E or something, T for type. So in this case, we are misusing the array list by leaving out the angle brackets and the types. Right? So this is not good. That's a raw type. That means that this, well, we'll talk about it in a second. This is what we meant, right? We're saying, hey, this is an array list, and in this array list go students. Right? And when we do this, it's guaranteeing the type safety of this class, and if we try to add anything but students, it's not going to work. In fact, it's not going to compile, which is even better, right? We really like the fact that at compile time, these things are going to be enforced. It becomes somebody else's problem to deal with the compile time stuff correctly, right? And of course, it forces us to do it correctly as well. So why don't we like raw types? Well, it's not expressive of the element type, right? When we leave it out, the reader's looking at it like, wait, what's supposed to go here? You're really just collecting objects? Really, anything in the world can go there? What are you going to do with an array list of just a collection of everything in the world, right? That doesn't really make sense. It doesn't explain what the array list is trying to do. So it's not expressive. Second one is it doesn't have type safety, right? We want to make sure that any code that comes after this that uses this array list only tries to put students in there. And once we have that, we also means we can call student methods, right? When you're in there and looking at each element, you know you can call student methods because the static type is going to be clearly student, right? So you know very clearly that everything is cool and that you're working with students. You can't do that with the raw type. And the other thing is, of course, you may find problems at runtime, and anytime we can take runtime problems and move them to compile time or find them at compile time, we always want to do that, right? Our code is just going to be cleaner. Now, you probably didn't intend to do this stuff, right? Often when you're creating this, you just forget, right? And it's often more insidious and easy and harder to find than something like array list. So often we do it unintentionally. We just are in a hurry and we don't think about the fact that we have forgotten the generic. Again, the compiler won't catch them. The good news is Xlint can do that for you. It can find those unchecked errors that are likely in your code. It can find those raw types that are in your code. So why would you not want to do that, right? Why as a coder, especially thinking about a professional career in it, why would you not want to get this extra information? We want that, especially when we're writing this kind of collection and data structure code. All right, so enough soapbox. Now let's talk about how you actually do the thing, right? Because the compiler can't do it, so how can you do it? Well, if you have a fancier IDE than we have, you might be able to turn that on to do this work, but we're going to sort of have to do it the hard way. So how do you do it using BlueJ? Well, first of all, you need to get you need to go to the command line, right? So what I'm going to do is I'm going to bring up our little project folder. Right, here's our bank folder, and it has all of our files in it, and we need to get to a command line. So this is a great trick. A student told me this that just amazed me because I thought I knew all the tricks about Windows. Obviously I don't. Here's a great trick. Click in the address bar and type CMD and hit enter. And when that comes up, it's going to be in the right folder, right? That's the key, is that it's going to come up into this folder, so I actually don't have to navigate. Yay! That saved me a lot of keystrokes in navigation. Right? So I first bring up a window, and then I need to know where javac.exe, the Java compiler, is. Now, if I'm clever, I know how to go add that path. So if you know how to change your environment variables and you want to add javac to your path, great, more power to you. If you don't, it's easy enough to navigate to it, right? We're going to start typing. We know it's going to be under program files. We know it's going to be under BlueJ. Now I'm just typing backslash and the beginnings of things like JDK. I know it's J something, and then I type tab and it's going to cycle through my options, right? But it's usually the first thing, and then bin, right? So I want to go all the way till I find javac, and then I again hit tab, and there's javac.exe. Right? So I need to be in the folder with my files, but call up the Java compiler from its folder, which is C, program files, BlueJ, blah, 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 blah. Then I put a space, and then I tell it what file I want to run it on. Now let me bring up my folder again. Now, which files do we want to run this on? The thing that you need to do is you need to find all of the files that contain your source code, but not your test code, right? Because really, this Xlint does not really understand test files, and you'll get some weird errors. So in this case, we want to check bank Java and bank account Java. Right, so in this case I can put a space, oops, that's not what I wanted. I can put a space, and then I can put bank account.java. And I'm going to hit enter. And it's going to go check that, right? Except, oops, I'm missing one thing, and that is I need to put Xlint, and then I need to tell it what type of errors I want to check for. I could put unchecked, I could put raw types, or I can put a comma and put both. So look carefully at the command line. I'm telling javac.exe that I want to run an extra special thing called Xlint, right? There's X commands, you can look that up if you want. And I want to check for unchecked errors and raw type errors, and I want to check bankaccount.java for those. Whew. That's a lot, so I recommend you make a batch file. I'll show you an example of one in a minute. All right, so I'm going to run that on bank account and see if it finds any problems. If it says nothing, then it found no problems, right? So in this case, bankaccount.java was pretty clean, but that's not a surprise. That's kind of a basic building block type of class. But what about bank? I'm hit up arrow. I'm going to go fix this. What about bank? Is that as clean? Oops, it's not. So notice, not only did it tell me, hey, I found a raw type, but look at this little arrow. It's actually pointing right at the offending thing. So it's telling me, hey, something's going on starting here. And then we see, hey, it's missing a type argument, right? It needs an element type. It needs a generic. So that's a pretty clear error. Right. Now, often other things that happen later, if you catch this raw type at the start, that might be the only real error. It could be that once you fix that, all the rest of the errors go away, right? So I would start and fix the thing closest to the top and then run it again and see whether that solves the problem. There's also, so that's a raw type, and then here's an unchecked call where I'm adding a particular thing here, right? I'm adding a bank account here, but it's like, okay, you're adding something, but it doesn't have any way to know to do any type checking on it, right? It's an unchecked call, so we don't know whether, whether the thing you intended is coming in here. So again, both of these are stemming from the fact that I forgot the generic right here, okay? So that is a great thing to be able to run and find those things, because you fix them, all of a sudden the quality of your code, the type safety, the number of runtime errors go down, the quality goes up, and now I'm happy, right, that I have found that stuff. So it's a great thing to know about, and you need to run it on your code as part of your assignments before you turn in your assignment. All right, and there will be some deductions if you fail to do that because it's so important, right? Okay, so that's great. We'll look at a batch file in a minute after we talk about the other option. The other thing that you can do here is there is a slide here. Pause if you need right now. If you're on the Mac, you can do this. This is from one of my former students. She gave me this about how to get this to work on the Mac, so hopefully that is useful to you. All right, now one more thing that you can do, it's not Xlint, but it's actually Xdoclint. This will go and check you on your JavaDoc notation. So if you're missing something, if you have something that is misnamed, or you're missing a parameter, you're missing a return, whatever it is, all you need to do is run Xdoclint. And in this case, you can just do :all, like, yeah, just run all your checks. Again, you don't need to do test files because it's not going to understand, I don't care whether you've done documentation on those. So how do I run doclint? So again, let me come back here, let me clear the screen, let me bring up, I'm going to hit up arrow until I get here, and I'm going to change my Xlint to Xdoclint. And I'm going to start with bankaccount.java and see if I'm missing anything. So pause there. I'm running the javac.exe, that's the compiler, but I'm telling it to do an Xdoclint run with find all warnings on bankaccount.java. And it'll come back and say, hey, when you declared this at line 15, private double balance, you didn't put a comment over it, right? You have an instance variable with no comment, and that's against the rules of strict notation, strict documentation. Great. Down here on line 23, there wasn't one for initial balance, right? So initial balance didn't have a param. So either you typed the wrong name when you did @param, or you forgot the @param altogether. Great. And on this one, right, public double withdraw, there was no return tag. It returns a double, but you forgot to put a return tag, so there's no return documentation. That's excellent, right? That's really good that it tells you you've forgotten stuff or you've misnamed stuff. That's pretty excellent, right? So now let's go see if bank has any of those. I think, yeah, bank is clean, right? So everything is good there. All right, so that's another thing that you can do. Now, in terms of using a batch file, because you might want to, sort of have this for every project, I have a fancier batch file, but this will certainly work. If I just bring up xlint.bat, I've created a batch file that looks like this. Right? For this particular project, I might do this, right? Where I do the required checks on both of these files, and then I do the doclint on these files as well. I put a pause between them so I know the difference, and I clear the screen between them so I clearly see that I've moved on to the different kind of results. So you can do something like this. You can certainly do something fancier than this. Like I have batch files that'll move all the test files into a subfolder and then run Xlint on everything and just try to be smart and run them all. But however you want to do this, you can certainly do it for a given project. And so this means that I can simply run that, right? So here I can simply run my xlint.bat and it'll run all of those types, right? So there's all of the problems with raw types and unchecked exceptions, and then I hit enter, and here's all my JavaDoc problems. So that is a super good way, is to make a batch file so that you can run this at intervals and not have to think about the specific files that you want to deal with. Or you can just let it give you the errors on the test files and overlook them, but they are a little bit annoying. So that covers a lot of the important stuff about using Xlint. And again, this is something that you're going to want to definitely do for your projects, both because you want to have cleaner code, and if you're in my class, because it's required as part of your project, and you'll lose some points if I see unchecked and raw types in your code. So hopefully that's useful. I think it's a cool set of tools. Hope you think so too, and thanks for watching this video.